Now we have a pretty decent caching strategy that is based on cached network from offline cookbook. Now we can display an application shell quickly and without connection. We still can't avoid stale content, but we can quickly notify a user that a new version is available after refresh. And I think this strategy is good enough to use in some real products. But still I'd like to find a simple strategy that provides only fresh content and without any tricky workarounds. Let's go back to where we started, a naive caching strategy called network falling back to cache. Let's make it a bit nicer. As we discussed before, this strategy will always return an old version of any resources that were cached on service worker installation. And for all other resources, it will just allow the default fetching behavior. It's not the greatest strategy because basically it can cache resources only once and forever, and user won't see any updates unless you install a new service worker. But let's flip the strategy and first go to network and then, if it fails, try cache. This scenario is also described in offline cookbook under the name of network falling back to cache. It's presented as a quick fix for frequently updated resources. Cookbook points out that with this strategy, a user will have to wait for resources that are already present on his device. I agree that this is not the smartest strategy and it basically gives us nothing except offline support. But for me the strategy looks very practical. You get one small improvement almost for free and without any drawbacks. In my table it has fairly modest results. We will cache an application shell on first visit like in any other strategy. Then for a user with a working connection it will basically do nothing. Such user will always get a fresh version with a common network delay. And of course I should mention that freshness will depend on HTTP cache as well. And an offline user will always get an app, but it will be the very first version that was cached on installation. The reason is obvious. We never update the cache when we handle fetch events. So let's fix that. Looks good, but that's what happens when you don't clone the response. Body is already used. Let's clone it. Now we have to kill the old service worker. Finally we have the new one activated. Let's try offline. It works well. But the main question at the moment is, can we display the latest version to an offline user? So again, let's make some change to the app shell. Go back online to download the new shell. Offline again, the new shell is displayed. So now the strategy performs a little better. Still nothing spectacular, just offline support, and unfortunately no gains in terms of quick rendering. But the coolness of this solution is that it's really simple and non-destructive. With this amount of code you make it work offline and you don't break anything else. And I think it makes a lot of sense to implement this strategy if you aren't ready to invest a lot into all these caching optimizations, but you're just looking for easy ways to improve the user experience. So let's decide the winner. What strategy was the best for the application shell? Personally, I like these two. They both provide quick and relatively safe improvements to the user experience. Network falling back to cache is just a very cheap solution for offline support. Cached network is a more sophisticated one. It provides both offline support and quick rendering, but it's slightly more complex, and it will also introduce a stale content. though we may reduce this problem by showing a notification about a new version. But if we decide to show such notifications, we will slightly distract the user from doing some meaningful stuff. Anyway, neither of the strategies alone will make a huge difference. Optimizing the application shell is a nice but very small improvement, and it just won't be noticed by most users. A really powerful caching strategy has to deal with various types of resources and handle each type differently. And such cool strategy will most likely combine many other strategies. So my small research was mostly a shallow introduction to caching strategies and how to reason about them. I didn't cover many other patterns from Offline Cookbook, like caching on network response, caching network race, and many others. I omitted them because they didn't seem relevant to the application shell, but of course you should understand them if you are trying to build something really clever.